students, welcome back to the discussion of the interesting chapter electrochemistry. And in this module we are going to discuss about the Faraday's second law of electrolysis. Students, from the first law of electrolysis we know that M, that is mass of substance getting oxidized or reduced, is directly proportional to the charge passing through the electrolyte. However, M, that is mass, is not only proportional to Q. It also depends on some other factor. So let us try to understand what that other factor is. Students, we very well know that every substance has its own atomic mass. So for the same number of atoms, different substances will have different masses, isn't it? For example, 4 atoms of sodium will have a mass of 92 U, unified unit. Whereas 4 atoms of silver obviously will have a mass of 432 U, which is different from sodium, isn't it? The number of atoms which are getting deposited on electrodes also depends on their number of valency. Now, how do we explain it? Suppose we consider 2 solutions here, electrolytic solutions of copper and another is electrolytic solution of silver. And these 2 cells are connected in series. Now here copper has a valency 2, whereas silver has a valency of 1, isn't it? Now, for reduction of copper ions, Cu2 plus 2 electrons giving you Cu, 2 Faradays of electricity which is passed will deposit 1 mole of copper because the valency of copper ions is 2, right? But at the same time, if we consider silver, Ag plus 1 electron gives you Ag. Silver has a valency of 1. So when I consider 2 Faradays of electricity, it will deposit 2 moles of silver. Reason being silver has a valency of 1. So from this example, we come to one conclusion. And what is that? If the valency is more, that is in this case it was copper, isn't it? If valency is more, then for the same amount of electricity, number of atoms deposited will be less. Here in this case, 2 Faradays were depositing 1 mole of copper, isn't it? So if valency is more, number of atoms deposited will be less. At the same time, if valency is less, then for the same amount of electricity, number of atoms deposited will be more. We saw it through the example of silver, isn't it? 2 Faradays was depositing 2 moles of silver and 1 mole of copper, right? Hence, students, here we can say that for the same quantity of electricity or charge which is passing through the different electrolyte, the mass of a deposited substance is directly proportional to its atomic weight and inversely proportional to its valency, right? And we very well know that atomic weight upon valency is nothing but equivalent weight, isn't it? So precisely here say that mass of a substance deposited is directly proportional to its equivalent weight. That is precisely Faraday's second law of electrolysis. So the statement, if I want to give you all, it says that when the same amount of electricity is passed through different cells, this is very important statement. So same amount of electricity passed through different cells containing different electrolytes and arranged in series, then the amount of substance oxidized or reduced at the respective electrodes are directly proportional to their chemical equivalent masses. I hope students this is very much clear to you all. Okay. So now let us consider one general example. You have electrolytic solution of A. Here you have electrolytic solution of B. They are connected in series. Okay. That is same quantity of electricity is passed. Therefore, moles of substance A which is produced in one cell, we know it is nothing but moles of electrons actually passed multiplied by mole ratio of A half reaction. Let us put this as equation number 1. Moles of substance B produced in another cell will be moles of electrons actually passed multiplied by mole ratio of B half reaction. We put it as equation number 2, right? So basically we have 2 equations here, and if we divide 1 by 2 here, what do we get? It is precisely moles of A produce upon moles of B produce, which is equal to mole ratio of A half reaction upon mole ratio of B half reaction. And this is precisely the mathematical representation of Faraday's second law. I hope students you have got a clear idea with respect to this. Thank you all.